Hey there, we are the Study Buddies. In today's mathematics addition video, we'll be looking at surds. So before we move to surds, I would like to explain another important part which we need to understand, to take note and to know before we move into surds. So as you can see here, 4 square means 4 times 4, which means you multiply 4 to itself twice. That's why it's called 4 square. And it gives an answer 16. So now we are aware that if we write a 4 square, you can get 16. But the question is how to get the base, which is 4. Just to remind you, this is called the base and this is called the index. So now the question is how to bring the answer back to its base. The answer is we have to use the root method. So what is basically the root method? Root method is the method of finding the base of a particular number. So how are we going to do that? So we would be starting it with this notation. So we have to write the answer inside here and we have to draw this symbol. So you may wonder, why is this divide? No, this is not divide. Divide looks something like this, but for root it looks like a tick over here. So don't mistaken it to divide, okay? So square root 16, or also called as 16 to the power of 1 over 2. So you may wonder why I'm not writing a number 2 here, because there is no square root 1. There's no square root 1 does not exist. So square root, if you want to mention a square of number 2, we don't need to write 2. But then let's say if you were to mention square root of number 4, then yes, we have to mention number 4 over there. Okay? So what does this mean? This means that we have a need to find what number times to itself for 2 times, that's why you have a 2 here, will get 16. So how can we do this in a long method? We can do it like 16, find the factors, 1 times 16, 2 times 8, 4 times 4, and here we find a match. So from this we get to know that 4 by 4 will get 16, same as what we saw in the index earlier. So square root 16 is going to give number 4, which means 4 multiplying by itself twice would give you 16. Okay, I hope you are clear with that. So now we are going to look at 16 to the root of 4, which means we need 4 numbers, 4 identical numbers multiplying to itself for 4 times. So what number can it be? So actually we can find it using various algorithmic methods, but I would suggest you to just use the calculator. So how can we do this in a calculator? So first you type out the number which you are going to root. So for this case 4, then shift and press this button. If you remember in the previous video in index, I've mentioned that this button is to notate powers which are more than number 3. So same goes here. Since this is more than number 3, we are going to use this symbol, and now you would see a root symbol over there, and then just insert the number which you need to find out, and the answer would be 2. So practically if you see 2 times 2 times 2 times 2, so 4 times, you are going to get 16 as well. Okay, so therefore 4 to the root of 16, you're going to get an answer 2. So now you can see that any numbers which, for example, square root 9, you're going to get number 3, square root 16, you'll get number 4, cube root of 8, you'll get number 2, and so on. But let's say now we have a number like this, square root 2. So square root 2, as mentioned just now, you need 2 identical numbers multiplying by itself together, you need to get number 2. So can you think of any number which after getting multiplied to itself, it brings to number 2? I mean, multiplying to itself twice brings to number 2. I think you can't find it out, but because there is no rational number which can stand in that position. So what we do is, again, we are going to use our savior, Mr. Calculator. So square root 2, you're going to get 1.4142, and the number goes on. It goes on. It does not stop here, but it actually continues till an infinite value. Okay, So these kind of numbers, if you watch my previous video on real number system, you'd be aware that these are irrational numbers. So now we are getting into the definition of surds. So surds are basically real numbers in a root producing irrational numbers. For instance, like square root 2, it produced an irrational number. Let's say I'm going to try off with square root 5, which is going to give another irrational number. So square root 9, let's say square root 9 is going to produce number 3. So is this a surd or not? Now look at the definition of surds again. Real numbers in a root producing an irrational number. So whatever producing an irrational numbers only are categorized as surds. But for this case, we can see that it's producing number 3. So is number 3 a rational or irrational number? Obviously it is a rational number because you can form ratio using number 3. So whatever numbers which are producing irrational values as its answer are called surds. So now we are going to look at the rules of surds. So if you remember, if you watched the indices video, you know that exponents had 5 rules, and now for surds we are going to see only 4 rules. So now let's move on to the first one. So you can see that I have written here a to the power of n, square root of n, is going to give a. And before I move to this rule, I would like to show you something interesting, where a square root of n can also be denoted as a to the power of 1 over n. Okay, so just keep this in mind and let's move on to this. So let's say I'm going to sub these values 4 and 2 inside. So it's going to be 4 square to the square root of 2. Okay, so let's begin solving. So 4 square is going to be 4 times 4, 16, and I'm not going to write the 2 again because I mentioned just now we have no need to write it. So square root 16, if you do it in the calculator, you are going to get 4 again, which brings us back to the same value where a equals to 4. Hence proven that 2 to the 10 is going to bring 4. How can we explain this in a much easier way? So 4 square root, right? So as I mentioned just now, square root you can bring it to as a fraction. So it's 4 square times with 1 over 2. So you just cut off the 2 and it becomes 4 to the power of 1, which brings back to the same value again. I hope it's clear. So the next rule is the product of AB, square root of the product of A, any power of root of the product of AB, if you split it, it's going to be the same. Like n to the root of AB is going to be n root of A times with n to the root of B. So let's just add these values into our equation here. So square root 216 is going to be equal to square root of 8 and square root of 27, cube root. Okay, so I'll solve this part first. So cube root of 8, you're going to get a 2, and cube root of 27 you're going to get 3, which brings to 2 times 3, 6. And cube root of 216, if you try it in the calculator, you're going to get number 6 as well, proving my point where this is equals to this. So whenever you see any question, let's say I'm writing 4 to the power of 16, so you can write it as 8, 2. You can just split it according to its factors. Like let's say I'm having number 400, so 400 can be 1 times 400, 2 times 200, 4 times 100, and it goes on until it reaches a point where it comes to 20 by 20. Okay, So when you do these kind of questions, when you see that you can't, or when you see some numbers where you actually can't do the root directly, you can actually split it to according to its factors. Okay, just now we looked at a rule where the multiplication can be split into 2. Now we are going to look at a rule where the division can be split into 2. Okay, so I'll solve this part first. So let's say square root, because n equals to 2, so it's a square root 25 over square root 9. So square root 25 is going to be 5 and square root 9 is going to be 3, bringing an answer 5 over 3. So on the other hand, square root 25 over 9, if I do it in a calculator, it's very important to put the bracket before you, if you were to cover a fraction, because without putting a bracket it leads to a wrong answer. Again, you're going to get 5 over 3, proving that yes, it's the correct answer. Okay, so whenever you see a fraction, you can just split the numerator and denominator and play the roots separately, which I prefer. So now we are in our very last rule, which is square root of n of a again square rooted with m is equals to m to the product of n square root a. So which one do you prefer? I think I'll just go with this one first. So m is 2, n is 3, square root of 64. So 2 times 3, you're going to get an answer 6, I think. So square root of 6 to the power of 6 to the base 64, you're going to get an answer 2, which is 2 times 2 times 2 times 2 times 2 times 2. Just to prove to you all, 2 times 2 4, 4 times 2 8, 8 times 2 16, 16 times 2 32, 32 times 2 64. Yes, that's the correct answer. And if I'm doing in this way, let's say, okay, so square root cube root of 64. So the cube root of 64 is going to give you an answer 4, and the square root of 4 is going to give you an answer 2, which tada, it matches. So therefore, this rule, whenever you see double roots for a particular number, you can just directly multiply the terms into one root, which makes it looks much simpler. So now we are going to move to our next part called Conjugate Surds. So the reason of explaining this will be explained in our next part of this chapter. And so how do you conjugate a surd? It's very easy. So what you have to do is you just have to change this, the order which is in front of the root, into its opposite. So a minus square root b. Let's say if the question is a c minus square root d, you have to change it to c plus square root d. So you just have to change this. That's the only thing you need to do. You don't need to disturb anything in front, okay? Just the ones which are in front of the surd. And very important thing, provided the number is a surd where inside the root you find an irrational number. So let's say if you see square root 3, square root 9, you no need to do this procedure, because you can directly get 3 and you can just settle the whole calculation, right? So therefore, conjugate is just changing the plus to minus or minus to plus. It depends on the question. So now let's continue with rationalization of surds. So this is the place where we'll be applying the conjugate surds thing. As a recap, conjugate means you have to change the plus to minus and minus to plus. But when it comes to rationalization of surds, which often comes in a fraction format, why we have to do conjugate is because of this disturbance, the square root d over here, or the surd d over there. So why do we actually have to change it? Why can't we just directly proceed with the calculation, but rather we have to simplify into another much simpler way? Because by logically you can't solve any equation. Let's say if there's an extra number, there are continuous numbers here, with this down here it is unable for us to continue with the calculation. Therefore, rationalization of surds is actually simplifying this equation, where we are going to change the denominator to a rational number. So we would not have any surds or any other irrational numbers there. Okay, so let's move on to our example. So now let's say we have to simplify this thing. So how do I have to simplify using the conjugate method is that I would just simply times this whole thing with the conjugate of the denominator only. So like practically I'm timesing the conjugate of the denominator only, which is 4 minus square root 3 over 4 minus square root 3. So how, you may wonder how can we just simply add something inside an equation? Logically, if you think, this is actually number 1, so there's no issue in adding this thing. Okay, so once we have this thing here, we just have to times the numerator to the numerator and denominator to the denominator. So 1 plus square root 2 times 4 minus square root 3 over 4 plus square root 3 times 4 minus square root 3. You are going to get an answer of 4 minus square root 3, which is 1 times 4, 4, minus square root 3, 1 times negative square root 3, plus 4 times square root 2 minus square root 3 times square root 2 over 4 times 4, 16, 4 times negative square root surd 3 is negative 4 surd 3, then 4 times positive surd 3 is going to be plus 4 surd 3, and surd 3 times negative surd 3, you're going to get something like that. So if we look at this, we can solve a few parts in this equation itself. So first thing, positive 4 square root surd 3 minus 4 surd 3. So you can just cut this off because the equation of this is just going to bring a 0. Next, square root 3 times square root 2. So if you remember the what we call that, the law of surds just now, we can actually just directly make this square root of 3 times 2, which is surd 6. And same comes to this one, where it becomes surd 3 times 3, which is actually going to bring to surd 9, and it's actually 3. So therefore we'll just directly continue with the equation. So 4 minus square root 3 plus 4 surd 2 minus surd 6 over 16 minus 3. Okay, so now if you notice, we have already changed the denominator into real numbers. So let's just finish off this whole thing. So 4 minus surd 3 plus 4 surd 2 minus surd 6 over 16 minus 3, 13. So this is going to be the answer, because we can't solve surd 3, we can't solve surd 2, we can't solve surd 6, because they bring to irrational numbers. So therefore this becomes the answers. So now let's move on to a few examples. I'll show you a few examples, and after doing the examples, a very important disclaimer: please do more practices. I'll provide you with some practices, but definitely please work more so that you can grasp the idea of this whole chapter. So let's look at this question. 3 plus surd 7 over 2 plus surd 7 minus 4 surd 7. So what we have to do is that we have to rationalize the surd, this part, because we have to change it to you have to change the denominator to a rational number so that we can solve the whole equation. So for now, let's just ignore this part and let's just focus on this. So 3 plus surd 7 over 2 plus surd 7 times with the, what do you call that, conjugate of the denominator. So 2 minus surd 7 over 2 minus surd 7. So when you times it off, it would be like 3 plus surd 7, 2 minus surd 7 over 2 plus surd 7, 2 minus surd 7, which brings off to an answer of 6 minus 3 surd 7 plus 2 surd 7 minus surd 49. I just directly multiplied the 7 and 7 together, over 2 times 2, 4, minus 2 surd 7 plus 2 surd 7 minus square root 49 again. Okay, now let's resume. So looking at this, we can see that we can solve some parts where positive 2 surd 7 minus 2 surd 7, we can just cut it off. Negative 3 surd 7 plus 2 surd 7 is going to give us off with negative surd 7. Square root of 49 is going to give off 7, and with the negative it becomes a negative 7. So 6 minus 7 over 4 minus square root of 49, which is going to give us a 7. So now you can see that the denominator is already a rational number. Okay, so now let's move on. We can see negative surd 7 minus 1 over negative 3 minus 4 surd 7. So we can just simplify this to 1 plus surd 7 over 3 minus 4 surd 7. So at last we have already rationalized the the fraction which we saw in the beginning of the question, and now we can continue to solve the part which I asked you to ignore just now. Now we can start to solve the part which I asked you to ignore just now, which is minus 4 surd 7. So parts after this is almost the same as how we solve a normal fraction question. So we are going to make everything have the same denominator, which means we are going to times this with 3. So 1 plus surd 7 minus 3 times 4, 12 surd 7 over 3. So 1, negative 12 plus 1 would be negative 11 over 3. So we just simplify this into 1 over 3 bracket 1 minus 11 surd 7. So this is the answer for this question. I know it is a very long calculation, but please do jot down so it would be easier for you to follow. Okay, so let's move on to our next example. Okay, so now we are looking at the question surd 2 minus x minus surd 3x plus 1 equals to negative 1. So what shall we do to answer this kind of a question is we have to try to remove the surds. So how to remove a surd? As I've mentioned just now, a surd is an undo of an index. So since it is a root of 2, we just times this whole thing with square. So let's square this whole equation, both sides, left hand side and also the right hand side. So it's surd 2 minus x minus surd 3x plus 1 square equals to negative 1 square, which brings us to an answer. Surd 2 minus x square is just going to give 2 minus x. Then multiplying these both together, you're going to get minus 2 surd 2 minus x surd 3x plus 1, and square of negative surd 3x plus 1, you're just going to get positive 3x plus 1 equals to negative 1 square 1, because negative 1 times negative 1, you're going to get 1. Okay, so let's bring the surds to one side and let's bring the rational numbers to another side. So 2 minus x plus 3x plus 1, bringing this 1 this side, it becomes minus 1, and bringing this whole thing to the right hand side produces 2 surd 2 minus x surd 3x plus 1. Okay, so let's solve this part. 3x minus x is going to produce 2x, 1 minus 1 0, so 2x plus 2 equals to 2 surd 2 minus x surd 3x plus 1. Okay, so now before I simplify this whole equation, I would like to solve particularly this part. So as we have seen in our rules just now, rules of surds, we can actually multiply both contents in the both of these surds into one surd. So 2 minus x 3x plus 1, which produces 3 times 2, 6x plus 2 minus 3x square minus x. Okay, so this side just remains for now. So we can actually simplify the equation now. Okay, so 2x plus 2, we can remove the 2 and make it x plus 1 equals to 2 square root of, so this would become negative 3x square. 6x minus x is a positive 5x, and plus 2. So we can immediately just cut off these two because it ratios to each other. So now the equation is x plus 1 equals to square root of negative 3x square plus 5x plus 2. So now we come back to the real beginning of this question itself, where we worked to remove the surd. So now we have to remove this surd in order to find out the value of x. So I'm going to times this whole equation with 1 square again, because this is a surd of 2. Okay, so x plus 1 square, and if you square this whole thing, it's actually just going to give you negative 3x square plus 5x plus 2. So x plus 1 square, you'll get x square plus 2x plus 1 equals to negative 3x square plus 5x plus 2. So now bring everything to one side. So negative 3x square, you bring it there, it's going to be positive 3x square. So 3x square plus x square, it's going to be 4x square. 5x bringing to this side, negative 5x plus 2x is going to be negative 3x. 2 bringing to this side, negative 2 plus 1, negative 1, and equals to 0. So now you have to solve this quadratic equation, and to solve this quadratic equation, I'm going to teach you a trick in the calculator. So mode 1, 2, 3. So press mode for 3 times, you'll see this symbol called EQN. Press number 1, go to degree. So since you see your whole equation is a power of 2 equation, so choose number 2, and now just input your values inside. So A 4, B negative 3, C negative 1. You're going to get answers 1 and negative 1 over 4. So therefore it's x minus 1, 4x plus 1 equals to 0, and therefore the answer for this whole question is x equals to 1 or x equals to negative 1 over 4. But for one reason, we have to reject x equals to negative 1 over 4. So why do we have to reject x equals to negative 1 over 4? Because if you look properly, let's say if I replace this negative 1 over 4 into the beginning of the question, which was surd 2 minus x minus surd 3x plus 1 equals to negative 1, it is going to be an undefined calculation. So why inserting a negative term inside a surd becomes undefined? So the calculator would explain the whole thing. Let's say if I put surd negative 1, which shows math error, which means that there's no answer for any question which is like that. So therefore we are just going to reject this negative 1 over 4, and the whole answer for this equation is x equals to 1. So I hope you all are clear with what I explained for this question. I know the question is very long, but yes, this is how this chapter is. So surds involves a lot of practice, so please do more practice. And I think that's all for our video. So if you like this video, please tap the like button, share it with your friends if you feel that your friends need more knowledge, more understanding on this chapter, and please comment on the comment section if you find any doubts. If you have any doubts, I'll definitely help you in the comment section. So that's all. Please and also please tap the subscribe button, and don't forget to press the bell icon for more notifications. So that's all. Bye bye, take care.